dive into 4.2.1, which is the introduction to microcontrollers. Now, this is one of my favorite topics inside of the digital electronics curriculum, and it's super fun. So today we're going to start off with an introduction to what is a microcontroller. So let's get started. Okay, so let's get started. So this presentation covers microcontrollers, microcomputers, and microprocessors. Something you will notice is that the micro in front of computers and processors in current times is frequently dropped. So we're going to go through, we're going to have an overview of all of these things, and then we'll talk about how you actually program these. So first of all, what is the difference? Let's start by taking a look at a microcontroller. So a microcontroller is a small, low-cost computer, and it's on a single IC. It has a processor, memory, as well as a programmable input and output. What you see in the picture there is an Arduino Uno. That is actually what we would have been working with if we were still in the classroom. And microcontrollers are used to perform one dedicated task. So they have one program on them at a time, and they're usually embedded into products for control. So a microcomputer is a small, relatively inexpensive computer with a microprocessor as its central processing unit. So it has a microprocessor, memory, as well as an input and output. What's in the picture is an incredibly old Commodore 64 microcomputer. I don't even remember those. So that's a throwback for sure. But we call them microcomputers because early computers used to take up entire rooms, as you know. So a microcomputer, by comparison with a keyboard, monitor, and mouse, are what we would call a personal computer today. So as I mentioned before, the prefix micro isn't really used as much as what it was. So, looking at some applications. So as we have the use of smartphones and mobile devices, we have to have changes in how we process things. So today, microprocessors in computers are often just processors. All computers have a processor as the CPU, and microprocessors are designed for use in mobile applications, and they're called application processors. So what you see on this Intel Galileo board, which is different than the Arduino Uno you just saw, is that in the center they're identifying the Intel Quark application processor. So again, application processors are for mobile applications. So a microprocessor, again, is an IC which has only the central processing unit inside. It only has processing powers. There's no RAM, there's no ROM, or any other peripheral installed on that chip. And a system designer has to add them externally to make them functional. So again, we drop that prefix micro and often just say processor. So now looking at microcontrollers, they're used to control a lot of different things: garage door openers, traffic lights, thermostats, robots, and they're embedded pretty much everywhere. And looking at the parts of a microcontroller, so a microcontroller contains a central processing unit, or a CPU, some form of memory, and a programmable input or output, abbreviated as I/O. So at what you see here is an Arduino Uno. We would have been working with these Arduino Unos, and right here you can see the microprocessing, the microcontroller on the Arduino board, and I'll show you the parts of this closer up in a moment. So some other parts that I want to point out. First of all, we have 14 digital pins across the back here, and you also get 6 of them that are PWM specific. So that means that they go to specific things and they all get tapped into the top parts, so that it's literally just like a breadboard on the top of them. On the other side, we have analog pins, 0 through 5, as well as where our power goes. So this is actually split into 2 sections where we have the analog and the power. And then over here we have the USB or external power supply. So if you're using an external power supply, you have to use between 7 volts and 12 volts. And it's a type B USB connection, so like you would use to plug in a printer. And then this has a 5 volt official Arduino software. We're going to be working inside of Tinkercad, so you can choose to program in the Arduino software and copy into Tinkercad for simulation, which is going to involve you downloading this. I will have those directions in the activity guide, or you can just program inside of Tinkercad. So a sketch, again, program written within Arduino, has variables, functions, so setup and loop functions, structures, and of course, comments. So the Arduino software consists of an integrated development environment, IED, and core libraries. The core libraries are written in C and C++, and they use some other libraries added to them. So the Arduino software language you program in is very similar to C++ because it's based on C and C++. So if you have taken a C or C++ course, or you've used it before, even Robot C, your experience there is going to be very similar as you're moving forward with programming these Arduinos. So here's an example program called Blink. So this sketch will continue to turn on LED 1 for 1 second and then off for 1 second. So the sketch program includes a setup function, which initializes the variables, the pin modes, and starting the use of the libraries. And then we have the loop function, which loops the code consecutively. And then anything behind the double slashes are comments. We also have void. The void keyword is used only in the functions declarations, and it indicates that the function is expected to return no information to the function to which it was called. So there's no print readout there. It's just blinking an LED and not giving us any other information. So something else that you're going to notice are the curly braces or curly brackets. They're a major part of the C programming language, and we have to always open and close our commands with those curly braces. And for beginning programmers and programmers coming to C from basic language, the curly braces can be a little bit confusing. So the curly braces in C replace the return statement in a subroutine, the end if statement for anything that's conditional. So and if this thing happens, the curly braces can replace that. And they can also replace a next statement in a for loop. So all things that if you're familiar with programming, that makes sense. If you are not familiar with programming, that slide just completely threw you for a loop. You're fine. So I would keep this slide in particular handy. So these are your main uses of your curly braces. So these are examples of how you would use it in a function, in loops, as well as conditional statements. So as you're working through the next couple of lessons, keep this slide in mind. So here's a closer look at that Blink program that we were talking about. And so you'll see the note at the top. It says that Blink turns on an LED for 1 second, then off for 1 second repeatedly. And again, this is an example code. So behind the slashes is saying that pin 13 has an LED connected on most Arduino boards. And then given the variable integer and the name LED. So integer LED equals 13. So what's that saying is that we now have an LED that is on pin 13. The setup routine runs once to declare the function when you press reset. So it has that void setup, and then it's going to initialize the digital pin mode as you defined as LED as an output. So you're going to say pin mode LED, you're saying it is an output. And then the void loop returns the program over and over again. So that is how it goes through and writes the program. So you're going to see that the digital write, the LED is high, it turns it on. The LED is low, turns it off. And then that 1000 is the 1 second. You'll also notice the curly braces strategically placed throughout that program to break it into different pieces. So a variable is a place for storing a piece of data and has a type, a name, and a value. For example, the Blink sketch declares that the type integer and the name LED has an initial value of 13. So variable data types include anything listed here. So we can have Boolean, we can have byte, we can have words, whole bunch of different options for your variables. It just depends on what you're trying to do. Looking at the function, so a function can also be thought of as a subroutine, and it names a piece of code that can be used elsewhere in the code. So the setup function is an example that sets the LED as an output. Basically, we're telling the circuit, hey, you are outputting something to this to create an occurrence of something happening. In this case, the LED blinking. And then we have the loop function, which is going to just continue that behavior, and that's where it's blinking the high, off for a second, low, off for a second, and it continues in that way. So it's getting that delay between the high and low signals. So now, couple of options for you. You can install the Arduino software as we are showing you, as I have in the activity guide, or you can just work inside of Tinkercad, up to you. And then we are actually going to be simulating a circuit today using a simulated Arduino board, a simulated 2-axis joystick, a simulated PIR sensor, so that's an infrared sensor, so cover, uncover situation, and then the very tiny accelerometer. So head on over to the activity guide, check out your assignment for this week, and we'll talk soon.